We are the senior design team about the sliding chair to aid the disabled in playing hockey. My name is Claire Swenson.
And I'm Mitrat Zine.
I'm Greta Danielson.
And I'm Josh Raisler. Our mentors for this project were Dr. Stewart and Dr. Selekwa. We were funded through the National Science Foundation. You can see our prototype here. We're going to tell you a little bit more about what went into the completion of our project.
Sled hockey is the adapted version of hockey, traditionally played by people with physical disabilities. The rules are similar to hockey, but athletes slide on sleds instead of skates and use two sticks that double as a means of propulsion. As a team, we met with a local sled hockey team organized by Hope Inc. They allowed us to watch their practice and learn more about sled hockey. We got the chance to ask the athletes what equipment problems they have, and the team organizers shared some of the problems they've seen with the sleds. When looking at the current sled design, we noticed how most of the hardware is hidden under the seat and is difficult to access. The backrest attachment is rigid and limits range of motion. The footrest does not secure the athlete's feet, and the riser system takes a long time to install. At this point, we decided to focus our design on customizability, both the amount of customizability for the athletes and the ease of customizability for team organizers. Because many athletes have disabilities, they cannot make modifications by themselves, and team organizers have to modify multiple sleds before practices and games. With this focus in mind, we developed concept designs and began creating 3D models. We were able to use decision matrices to choose which concepts to include in our final design. We also completed finite element analysis to ensure that our sled could hold up to 250 pounds, a typical capacity for sleds. After completing the design phase, we moved on to manufacturing, which we completed using NDSU's resources. We molded the footguard using a 3D printed prototype, and we bent the nose piece using a custom plywood jig. We also ordered the off-the-shelf components and the hardware we would need to complete our prototype. At this point, we had a completed prototype. So let's take a look at how we were able to address the problems that we observed with the current sled. We modified the base of the frame to create more clearance for changing the sled length and blade width. Our backrest design provides increased mobility for the athlete while still providing support. The footguard has a platform for the athlete's feet to rest on and is surrounded for added protection. The seat height is adjustable, so a riser does not need to be added for an athlete to tilt the seat or change the height. Now we need to complete testing to see how our sled performed on ice. We were able to rent ice time at 2 local arenas because all the outdoor ice melted due to an early spring. Since we had never played sled hockey before, it took some practice to learn how to balance, start, and stop. There was definitely a learning curve to the fundamentals. We compared our sled against the current sled to ensure that our sled had similar performance on ice. We set up 3 tests to cover basic hockey movements. The first test involved moving between cones to test maneuverability and speed. The next test was a start and stop test to see how fast the sled can travel from blue line to blue line, and then how fast it can stop. The final test was a down and back test to see how fast the sled can change directions. After completing multiple trials, we were able to conclude that our sled performed similarly to current sleds on the market. Additionally, we performed some off-ice tests to evaluate some of the other features. We were able to try out range of motion from the backrest, as well as added balancing legs from the seat attachment, an added bonus to making the seat height adjustable. A final validation of our design was to evaluate how easily the sled could be customized. We were able to change the blade width in about 2 minutes with no tools, a much easier modification than can be done on current sleds. The most rewarding part of the testing phase was showing our prototype to Hope Inc. and their athletes. The kids' faces lit up when we saw that we had designed something for them. Hope Inc. is anxious to try to set out at their hockey camp next year, and hopefully more senior design groups can partner with them in the future to work on more projects. Our project would not have been possible without the help of a lot of people. We'd like to thank the National Science Foundation for their funding to complete the project, Dr. Stewart and Dr. Selekwa for being our mentors, Dr. Alvin for directing the senior design course, Hope Inc. for their input and feedback, the NDSU department for the facilities and knowledge, Shannon for helping with machining, and Laura, Kim, Tanya, and Tiffany for helping with orders, budget, and anything else we asked for help with. This project would not have been a success without each of these people's help. We hope you enjoyed learning more about our project. Thanks for watching.